The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to try and wrap up this massive review we've been doing. We're going to continue and hopefully get finished with outcome 5. And then Monday during regular class time, I will be here to answer whatever questions people have, anything they want to look at from the past. I won't have a specific agenda myself, just be an extra review for people that still want more. Anyway, so now we're going to go ahead and continue from yesterday, starting with question number 22. So let me get to a blank screen. And here we go. All right, number 22, it says, simplify the expression completely. We have in parentheses, a to the -2 power times b to the 7th power, the whole thing to the -2 power. So there's a couple of different ways we can approach this. One way is we can say, well, we have a product raised to a power. So we'll take each factor of the product and raise it to that power. But a power raised to a power, you multiply the exponents. -2 times -2 would be +4. 7 times -2 would be -14. And then taking b to the -14th power, moving it down into the denominator, b to the +14th power. So there's an answer, okay? Another way we could do this same problem is we could say, well, let's see, let's take what's inside and rewrite that, moving a to the -2 power down below, making it a to the +2 power. So then we'd get this, and then we could take the quotient and flip it over to change the sign of the exponent. And then we could apply the outside exponent to the top and to the bottom, and once again, get the same answer. So there may be more than one way to get to the correct answer, as long as all the moves you make follow the rules. Any questions there before we go on? All right, then we'll go on. Let's see here. Number 23, 8 to the 0 power over q to the -9th power. 8 to the 0 power, well, anything other than 0 to the 0 power equals 1. So we have 1 over q to the -9th power. Then moving q to the -9th to the top becomes q to the +9th, and 1 times that would just be q to the +9th power. Well, I guess I never, hang on a second, my bad. Back here, I never put that answer in there. I should have done that. So we'll go ahead and do that. A to the 4th power over b to the 14th power. Sorry about that. And then going on to this problem, 23 would just be q to the 9th power. So let's see here. Q to the 9th power. All right. On to number 24. Simplify completely. -5 times r to the 4th over r squared times z to the 5th, the whole thing to the -3 power. Well, inside the grouping symbol, inside the parentheses, I can take r to the 4th on top, divided by r to the 2nd on the bottom, and get r to the 4 minus 2 on top. So r to the 2nd power. So I get that. Then I can take the reciprocal of the quotient inside the parentheses and that changes the sign of the exponent. Now, it doesn't change the sign of this coefficient. It just changes the sign of the outside exponent, okay? So that's still a -5 in the denominator. So now I'm going to take the outside 3 and apply it to z to the 5th cubed over -5 cubed times r squared cubed. Now I get z to the 15th power over -125 r to the 6th. Now, typically, you don't leave a negative sign in the denominator, so you would either apply it out in front or apply it to the numerator. So either one of those, I'm going to go with that first one. Actually, you know what? Let's see what they did. Yep, they went with the first one. Okay. I never know for sure which way they're going to write it. Okay, so negative. Then we're going to use the fraction. In the numerator, we've got z to the 15th power. In the denominator, 125 r to the 6th power. All righty. Going on, number 25. K cubed over r squared, the whole thing to the -2 power, would be r squared over k cubed, the whole thing to the +2 power. Now I have a quotient raised to a power, so I'll apply that outside power to both the numerator and denominator of the quotient. Power raised to a power, you multiply the exponents, so r to the 4th over k to the 6th. Let's see here. R to the 4th over k to the 6th. Going on to number 26. Let's see here. Simplify the quantity 3x squared to the 0 power. That 0 on the outside applies to everything inside. So basically, I could just go right ahead and say the answer is 1. If you're not convinced of that, we could drag it out a little longer and we could say, well, that's 3 to the 0 power times x squared to the 0 power, which is 3 to the 0 power. Let's see, 2 times 0 would be 0. So you'd get that, which is still 1. So any way you go about it, you should come up with just plain old 1 as the final answer. All right, scientific notation. Number 27, rewrite this number in appropriate scientific notation. So 573 would be 5.73 times 10 to the 2nd power. Now, I know they had some different ways of having us write it out. It doesn't say anything here in terms of how to do it. So I'm going to assume that the asterisk key is going to be the multiplication symbol. We'll find out here. Let's see, 5.73, and then shift 8, which gives me the asterisk symbol. Yep, that seems to be working. It says not valid. We'll see. Well, because I'm not done yet. And then 10 squared. So let's see if it likes that. Let's see how they did it here. Yeah. And again, how you would get that X multiplication symbol. Again, I'm using the asterisk key. Okay. 28. Rewrite this number in appropriate scientific notation. 0 point, let's see. We have 1, 2, 3, 4, 5 zeros followed by 8, 5, 6. Let's make sure here. 1, 2, 3, 4. Yeah. So 8.56 times 10 to the 1, 2, 3, 4, 5, 6, but that's going to be -6 power. So 8.56. And then shift 8 times 10 to the -6th power. All right. So here, this is a situation where you would leave a negative exponent. When you're not dealing with scientific notation, like in a lot of the previous problems, typically you don't leave a negative exponent. You put it on the other side of the fraction bar and change the sign of the exponent. Okay, number 29. Rewrite this number as a whole number or decimal, 1.4 times 10 to the 4th. So we're going to move the decimal point 4 places to the right. 1, 2, 3, 4. So 14,000. Notice I didn't add 4 zeros. I only needed 3 zeros because the first movement of the decimal point just went across the 4. So 14,000. Okay. Again, if you have any questions about anything, please stop me. Otherwise, I'll just continue. Rewrite the number as a whole number or decimal. 9.25 times 10 to the -7. So what that means is we're going to move it 7 places to the left. 2, 3, 4, 5, 6. So I'm going to go 1, 2, 3, 4, 5, 6, 7. Okay. So I'm going to get 0.1, 2, 3, 4, 5, 6, 9, 2, 5. Okay, so 0.1, 2, 3, 4, 5, 6, 9, 2, 5. All righty.
Would it work if we didn't put the 0 in the front?
Yeah, it should be okay. Let's tell you what, let's get rid of it. See what they do. Yeah. The reason that I always do that as a habit is it, especially when you're working with a problem that doesn't have a bunch of zeros. Let's say that you've got, well, a good example on the corner of Nob Hill and 40th Avenue. I don't know if you live here in Yakima, but there's a sign talking about a bridge coming up. And I think it says something like 0.4 miles ahead or something like that. Now, in that case, if you're driving by quickly and it was written like this, you might not see the decimal point, but writing it this way, since you wouldn't write plain old 4 like that, the decimal point or the 0 kind of draws to the fact that it's not 4, it's 0.4 miles, because you know, driving by quickly, you might not catch it. Now, sitting here looking at this stuff, it doesn't really matter, but I just kind of have the habit of putting that 0 in front for situations like that. So there's the lengthy explanation to your question. Okay. All righty. 31. Represent 1.00459 times 10 to the -5 power in decimal form. Okay. So we're going to move it 5 places to the left. So 1, 2, 3, 4, 5. But again, I'm going to put that leading 0, even though it's not required. So that, and then. Let's see here. I've got what, 4 zeros followed by a 1. Oh, but there's, yeah, this one's not right. That one's not right. I think this one, let's see, 4 zeros, and then 1 0. Yeah, it's this one here. Okay. Number 32 coming up. Write the number in scientific notation. 7,500,000 would be 7.5 times 10 to the 1, 2, 3, 4, 5, 6th power. So 7.5 times 10 to the 6th power. And again, I'm using the shift key and then the asterisk above the 8 as my multiplication dot. All righty. Number 33. Write the number in scientific notation, 0.84. So that would be 8.4 times 10 to the -1 power, since we had to move the decimal point one place to the right. So 8.4 times 10 to the -1 power. $34. Write the number in standard notation, 6.6 times 10 to the 5th. So we're going to move it to the right 5 places. So 1, 2, 3, 4, 5, comma. So 660,000. Moving on. Number 35. Is this in scientific notation? No, it's not, because there's more than one digit, non-zero digit to the left of the decimal point. So it's not in scientific notation. All right. Let's see here, 36. Okay, now, if you'll recall back when we did the section on significant digits, the problems were all kind of inconsistent, everything. There won't be any problems like this on the final. I am going to go ahead and do the first part of this problem, but as I recall, it was the second part of the problem that they were inconsistent. So let's just take a look at the part A. Okay, multiply. So we've got, let's see here, part A, 3.4 times 10 to the 1 power times 2.487 times 10 to the 5th power. So I'm going to take 3.4 times 2.487 and then times 10 to the 1 times 10 to the 5th. So 3.4 times 2.487, I get 8.4558, and then times 10 to the 1 plus 5 is 6. But there's only 2 significant digits there, so there'll be only 2 significant digits there, so we round the 5 up. So this should be the correct answer, which is right there, and we'll check it out there. Okay, now I'm not going to do part B because, like I said, those were inconsistent, so we'll just skip that. Okay, what did I do here? Oh, this is 36. Sorry about that. Okay, 37 coming up. Multiply the following and express your answer in appropriate scientific notation. It doesn't say anything about significant digits here. So let's see here. So we're going to have 3.8 times 6.7 times 10 to the 45th power times 10 to the 28th power. Okay. 3.8 times 6.7 is 25.46. And then times 10 to the 45 plus 28 is 73rd power. However, this is not in scientific notation. It needs to be 2.546. So my next step for my next trick, I'm going to take this, let's see, this thing here, and rewrite just that part of it in scientific notation. Okay. Then this would also be times 10 to the 73rd power. Then I'm going to combine my powers of 10. So 2.546 times 10 to the 74th power. So again, the problem was when I multiplied these, this was not scientific notation. So I needed some additional adjustments there. So 2.546. Oops. Oh, read the directions. Here, let's see, you would type X. So apparently I can use the X as a multiplication dot. I wonder if I need to put a space in there. Let's find out. And then 10 and the caret key, which is above the 6, and then parentheses 7, 4. All right. Have I done that correctly? I believe I have. That's another thing I noticed on the test. A lot of people, you had the right answer, but it marked it wrong because you didn't do it this way. So technically, you're not following directions, like I almost didn't do there. So just be careful with that. But no, Eric, that doesn't count as a mistake because I caught it before I did it there. So Eric keeps track of my mistakes for me. He's gone through a huge pile of paper this quarter, writing that all down. Okay, we're going to do 38, but again, we're just going to do the first part. Divide, so 4.282 times 10 to the 6th power over 8.166 times 10 to the 4th power. So I'm going to do this first part. Let's see here. 4.282 divided by 8.166. Oh my. Here's what it gives me. Let me make sure I got this. It gives me 0.524369336. And I'm not sure if that's the final answer or if it keeps going from there, but not to worry, not to worry. Times 10 to the what? 6 minus 4 is 2. So we get that, okay? So far, so good. Now, this is not in scientific notation. So I'm going to take this number and move the decimal point over, okay, which is going to make it times 10 to the negative 1 power because we had to move it to the right, and then times 10 squared. Okay, so then I'm going to get 5.243693336 times 10 to the 1 power. But least number of significant digits, and we have what? 4 on top, 4 on the bottom. So we want 4 of them right here. The 6 would round up, so 5.244 times 10 to the 1 power. Let's see. 5.24. Here we go. All righty, and there you go. Again, we're going to skip part B just because we had issues with it before. $39. Same.
Is part B going to be on the test?
Sorry?
Is part B going to be on the test?
No, you must have missed it. I mentioned that a little earlier. Yeah, won't be. There won't be anything involving significant digits on the test.
Okay.
So there won't be part B or part A, but I'm doing part A anyway, just for the practice. Okay, because you will encounter that later on in some of your science classes. All right, 8.5 times 10 cubed over 1.3 times 10 squared. So let's take that part. 8.5 divided by 1.3. And again, I get this huge number, 6.538461538. And then times 10 to the third divided by 10 to the second is 10 to the 1. This is in scientific notation already. I have two significant digits on top, two significant digits on the bottom. So we're going to round down. So 6.5 times 10 to the 1 power, which is right there. Okay, again, we're going to skip part B. And here comes number 40. Evaluate 2.55 times 10 to the negative 8 power times 5.11 times 10 to the 5th power. Says express the result as a decimal. All right, so 2.55 times 5.11, and then times 10 to the negative 8 times 10 to the 5th. Let's see, let's do this first part. 2.55 times 5.11 is 13.0305, and then times 10 to the negative 8 plus 5 would be negative 3. But we want to express this as a decimal number, so I need to move the decimal point to the left 3 places, 1, 2, 3. So I'm going to end up with that, which is, let's see, I think it's that one. Yeah. Okay. All righty, number 41. Write the number in standard notation. 5.6 times 10 to the negative 153, and then times 8.6 times 10 to the positive 154. So we get 5.6 times 8.6 times 10 to the negative 153 times 10 to the positive 154. And 5.6 times 8.6 is 48.16 times 10 to the negative 153 plus positive 154 would be positive 1. Standard notation, so we're going to move it one place to the right, 481.6. Let's see here, 481.6. Okay, moving along, number 42. Basically, same kind of problem. 5.9 times 10 to the negative 151 power times 6.7 times 10 to the 154 power. So I've got 5.9 times 6.7 times 10 to the negative 151 times 10 to the positive 154. 5.9 times 6.7 is 39.53 times 10 to the negative 151 plus 154 would be positive 3 power. Standard notation. So I'm going to move the decimal point 3 places to the right, and I should get 39,530. 39,530. And continuing on. Number 43. Again, if I'm going too fast, let me know. I can slow down. Write the number in standard notation. 5.6 times 10 to the 16th power over 1.4 times 10 to the 23rd power. 5.6 divided by 1.4 is 4 times 10 to the 16 minus 23 would be -7. Okay, but I'm supposed to write this in standard notation. So I've got to move it 7 places to the left. 1, 2, 3, 4, 5, 6, 7. So 0.023. Let's see, how many zeros are there? I got 6 of them to the right. Yeah, 6 of them to the right, followed by a 4. Okay, so 0.1234564. Okay. Number 44 coming up. Go. Multiply 6.48 times 10 to the 7th times 6.5 times 10 to the 4th, 6.48 times 6.5. Let's do this because otherwise we might think that decimal, don't want to confuse a decimal point with the multiplication sign, times 10 to the 7th times 10 to the 4th. So 6.48 times 6.5 is 42.12, and that's times 10 to the 11th power. Let's see, expressing answer in scientific notation. So this is going to be 4.212 times 10 to the 1, and then times 10 to the 11th power, because this, written in scientific notation, would look like that. So 4.212 times 10 to the, 12th power. But our least number of significant digits is 2, so it's going to be 4.2 times 10 to the 12th, which is right there. Okay. And again, we're not going to do part B. 45 coming up. Okay, 2.43 times 10 to the -10 power times 5.31 times 10 to the 5th power. Express the result as a decimal. So that's 2.43 times 5.31 times 10 to the -10 times 10 to the 5th. So 2.43 times 5.31 is 12.9033 times, let's go, times 10 to the -5th power, -10 plus 5, but as a decimal. So we're going to move it 5 places to the left. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 0.000129033. Let's see, I've got 3 zeros and then 1 to 9033. This one right there. Okay. 46 coming up. Multiply the following, express your answer in appropriate scientific notation. 6.7 times 10 to the 36th power times 6.8 times 10 to the 26th power. So we're going to have 6.7 times 6.8 times 10 to the 36th power times 10 to the 26th power. 6.7 times 6.8 is 45.56 times 10 to the 36 plus 26 is what, 62? But that's not scientific notation. So this is going to be 4.556 times 10 to the 1 power. And then this is going to be times 10 to the 62 power. So we're going to have 4.556 times 10 to the 63rd power. Okay, so I took this, wrote it in scientific notation, then combined the powers of 10. All right, and we're supposed to write it in this form here. So 4.556 space x space 10, a little caret key. So let's see, parentheses 63 close parentheses. All righty. Continuing on. Number 47, write the number in standard notation, 7.2 times 10 to the 19th power over 1.8 times 10 to the 17th power. 7.2 divided by 1.8 is 4 times 10 to the 19 minus 17 is 2 power, but this is a standard notation. So we're going to move it 2 places to the right. So our final answer should be 400. Okay. 48 is really the same kind of thing as 47. They just wrote the division out in that form instead. But we could take it, let's see here. Number 48, it says 9.52 times 10 to the negative 73 power divided by 5.6 times 10 to the negative 34 power. We could write that like this. Let's see, 73, 34. Okay. And then this would be, let's see here, 9.52 divided by 5.6 is 1.7 times 10 to the, I've got negative 73 minus negative 34, right? Because it's top exponent minus bottom exponent. Subtracting a negative is like adding a positive. So we've got negative 73 plus 34. Which is negative 39. This is in scientific notation, so I don't need to do any further adjusting. Let's see here. It doesn't say which way, so I guess we use the asterisk key on this. 1.7 times 10 to the negative 39th power. The reason that there's different forms of problems where some places you use the asterisk and some places you use the caret key is that these problems were not all generated by the same author. There's like this big pool of problems that are, and then you go through and pick ones out of the pool, so to speak. All right, 49. Divide the following and express your answer in appropriate scientific notation. 5.643 times 10 to the negative 6 power over 5.7 times 10 to the negative 45th power. Okay, so we'll do the first part. 5.643 divided by 5.7 is 0.99, and then times 10 to the top exponent minus bottom exponent. So negative 6 minus negative 45, subtracting a negative is like adding a positive. Negative 6 plus 45 would be what? 39. So I get that. However, that's not scientific notation. So this becomes 9.9 times 10 to the negative 1 power and then times 10 to the 39th power. Okay, and then this becomes 9.9 times 10 to the 38th power. So 9.9, and let's see here, times 10. I'm gonna move this out of the way here. To the 38th power. Okay, and number 50, running out of room here, that must be the last one. Okay, number 50. Write the number in standard notation, 6.4 times 10 to the 24th power over 1.6 times 10 to the 22 power. And 6.4 divided by 1.6 is 4 times 10 to the 24 minus 22 is 2. So I get 4 times 10 squared, but it says standard notation. So we're going to move it over 2 places. So it's going to be 400. There we go. 400. All right. So that's all I've got for today. I will be back this afternoon at 1:15 with an office hour. Monday at 10:30 will be our last review session, and that is just a free for all. In other words, I don't have an agenda. I'm not going to go over specific things. We've gone over every problem on every review from every objective or whatever, never remember the word they call it, outcome. But if you want to stop by Monday, you can. There won't be any office hours next week, and there won't be any official meeting on Tuesday, the day of your final. So if I don't see you this afternoon, I might see you Monday. If I don't see you Monday, well, have a nice life. Don't make sure you finish your final by Tuesday evening, 11:59. Do not bother to email me asking me for grades. When they're all done, I will email each one of you individually and tell you what grade you got in the class. Okay. So and I will do that after I've corrected all the finals. So that might not happen until Wednesday or Thursday of next week. So you can send me all the emails you want about, Mr. Mayo, what's my grade? I will just ignore them until I'm ready to send them all out. All right. I'm going to go ahead and stop the recording. Eric, stick around for a second. You're not in trouble.